Hey, greetings. We're continuing our look at probability and odds today, and I've got 3 problems selected for us that we're just going to kind of look at from the book. So here's example 6 from our text. It says 12 male and 16 female students have been selected as equal qualifiers for 6 college scholarships. All right, if the awarded recipients are to be chosen at random, what are the odds? Okay, man, you always trick. I'm such a fan of probability, and then they throw odds in there, and I'm like, I answered the wrong way. What are the odds that 3 will be male and 3 will be female? So the first thing I would recommend doing is actually finding the probability. So let's find the probability: 3 male, 3 female. So how many ways could I select 3 male candidates for the scholarship? Recipients, I guess. Yeah, combo 12-3. So there's 12 males to pick from, and I'm choosing 3. And I then have to multiply by the number of ways I could select 3 female candidates or recipients. And there's 16 over. And how many candidates were selected from total? Well, there were 6 selected, and out of the total of 28, right? So that would be my setup for probability. Let me use a calculator on this one. 12 combo 3, I combo, U combo, combology, the study of combo. Let's see, here we go. Times 560 over, let's see, I have a feeling 28 combo 6 is probably going to be a big number. I've got a hunch. Yeah, alright, I guess not necessarily that big. People buy houses this expensive. It's a big number for me, I don't know. 220 times 560. 1, 2, 3, 2 hundo over 3, yeah. 3, 7, 6, 4, say, nope. 740, wow, man. Wow. All right, there we go. And so that's the actual number of ways that it could occur. But let's reduce that. It's sometimes worth knowing that just so you kind of have perspective of like, okay, that's the number of ways I could have selected 3 male and 3 female. So divide by 3, 7, 6, 7, 40. Looking at that, by the way, if I was reducing this by hand, I would have immediately gotten rid of the zeros, dividing top and bottom by 10, and then I'd realize, 4 and 20. Both of those are probably divisible by 4, but I would start with 2, and I just keep dividing by 2, and then keep reducing from there. But I think sometimes a calculator can just do the math frac, and bam. Sometimes the technique on the calculator is really good. 880 over 2691D. There we go. And apparently it doesn't reduce from there. I'm guessing. So that would be the probability. Now question, what about the odds? The odds of 3 male, 3 female. Well, the numerator is the same. That's the number of successes. And the denominator originally was S plus F. So if I just wanted the number of failures, I would just take 2691 and subtract 880, right? And I get 1811. I wonder what happened in the year of 1811. I don't think that reduces. Does it? Nope. And by the way, that's about 0.4859. So that's about 48.59% chance of that occurring, if you're wondering. So that's the idea. We're getting used to the idea of having to do combinations from multiple groups like that. It's not that bad. Not that bad at all. So let's see, scrolling down. Let's see, it says there's 7 kittens in a litter. 4 have stripes. 3 kittens are picked at random. Find the odds of each event. So let's see. First I'm going to go through and find the probability. So probability 3 stripes. So 4 have stripes, so that would be combo of those 4. I'm picking 3 over, I'm picking from 7, 3, right? So I think 4 combo 3 is just 4, if I'm not mistaken, and I am not mistaken. And 7 combo 3 is 35. So 4 out of 35 chance of that occurring is the probability. So the odds of 3 stripe, I'll just call it 3S, would be 4 to 31 would be the odds, right? All right, let's figure out probability of 1 stripe. So let's see. How would I figure that out? Well, I'm picking 1 from the striped cats. But that's not the only kitten I'm picking. What else do I have to consider for the number of successes? I have to pick 2 more cats out of what group? Non-stripes. And how many non-striped cats are there? There's 3. Right? If I don't take this into account, I've actually far undershot the number of possibilities. So be careful there. And the denominator is the same. So let's see. So that's going to be 4 times 3. I think that's 12. Yeah, 3 combo 2 should be, yeah, 3. So 4 times 3, 12 35ths is the probability. So the odds of 1 stripe would equal 12 to 35 minus 12 is 23. Is the odds of getting exactly 1 striped kitten. All right, the next question is the probability or odds that 1 is not striped. What's another way you could phrase that? Yeah, so the probability of not striped is the same as the probability of 2 striped. All right, I just want to make sure we understand the language that they can phrase these sometimes in a negative or different ways. So the probability of 2 striped kittens, 2 striped is the same as 1 not striped when I'm selecting 3. I'm just trying to write it in the same language as the other ones. So to select the 2 striped, that would be combo 4, 2. To select the 1 not striped, I would be selecting 1 from the 3 not striped, and then combo 7, 3. So let's see, 4 combo 2 is 6. 6 times 3 is 18 out of 35. Let's see, does that reduce? No. So there's the probability. So the odds of 1 not striped would be 18 to 17. So that means it's more likely that you'll get this situation than any other, right? In fact, than the sum of any other, right? Because 18 out of 35 is more than 50% likely. Now, question, let's see. Look at this. 18 plus 12 plus 4. Is it? 18 plus 12 is 30, plus 4 is 34. out of 35. So I've counted 34 of the 35 possibilities. Right? The situations we've considered are 3 stripes, 1 stripe, 2 stripes. What's the only other situation that could happen? No striped cats. Correct? So let's figure that out. And in theory, I already know the answer. It has to be the other 1 out of 35 possibilities. Well, let's just verify that. So probability, no striped, or 0 striped. So what would that mean for my successes? There are 3 not striped, and I'm picking all 3 not striped. Out of combo 7, 3. Combo 3, 3 is in fact 1 out of 35. So I just want to point out that notice that all of those fractions add up to 100% likelihood, right? I'm not going to reach into this and then suddenly grab a leopard. I don't know. I'm not going to get some striped, not striped, and then some third possibility. I've considered all possible outcomes here. So that's why if I add those all up, I would get the complete 100% probability. So the odds of not striped, no striped rather, would have been what? 1 to 34 odds, right? So it's unlikely, if you randomly did this, right, that you would have gotten the not striped ones, and all of them not striped. But this idea of the probabilities adding to 1 is going to be helpful later on. Let me ask one more follow-up question maybe. What's the probability of at least 2 striped? Or maybe could you phrase that for me differently? That would be the same as asking what? Probability 2 striped and the probability of 3 striped, right? Is another way to say at least 2. So I should just be able to add those. So 18 35ths plus 4 35ths. And I get 22 35ths. So I just want to point out that for a question to have the words at least or less than requires you to find the exact situations, all right, and then either add or subtract probabilities and figure it all out. But we are able to figure that out, which I think is kind of cool. All right, one more question. We're doing good. We're doing good. Here we are. This is question 41 from our text. It says, Miss Robinson gives her pre-calculus class 20 study problems. She will select 10 to answer on an upcoming test. Carl can solve 15 of the problems. Okay, so find the probability that Carl can solve all 10 problems on the test. Okay, so probability of Carl solve all 10. Okay, so what does that mean? All right, what do we consider a success? When he can solve all 10. So and specifically, I'm selecting all 10 problems from the ones that Carl can solve. This C is not for Carl. This C is for combo. By the way, Carl with a K is the cooler way to spell it. That's how my bro spells it. Represent, younger brother. Give him a noogie. So here we go. How many problems can Carl solve? 15. So success would be selecting all 10 out of the 15. Right? Over the total number of ways, she could select 10 questions for the test. So that'd be, yeah, combo 2010. Let's see. So, let's see. I'll start with the 15. 15 combo 10. We've seen this number before. 3003. And 20 combo 10 is 18,4756. And I wonder if this reduces. It's a 1.6% chance of occurring, if you're wondering, and it reduces to 21 over 1292. It's about 1.63% chance of occurring. For the teacher to, randomly select all the problems that Carl knows how to solve. All right. Chances are she's going to select mostly problems that he knows how to solve, but for all of them, it's not going to be that likely. All right, and let's see. For B, it says, and we did want to find probability for the first one. This one says odds. We might figure that out. We'll do at least probability. Let's see. It says find the odds that Carl will know how to solve 8 of the problems. Probability, solve 8. So what would that look like for success? How many ways could the successes occur? So combo 15, 8. Not quite. I have to multiply this by another combination. Where are these other 2 problems being selected from? No. 5. Specifically, the 5 problems that Carl didn't know how to solve. So 20 minus 15. Right? If I pulled out a 20, there's still a chance that what if I chose either one of the problems we'd already considered or one of the other problems that Carl knows how to do right. So I had to specifically count that these 2 are ones he definitely doesn't know how to do, and that's why I had to have it set up that way. So combo 2010 equals, let's see, so 15 combo 8 is 6, 4, 3, that's an ugly 3, 5. Combo 5, 2 is 10, all right, over the same denominator that we had earlier, 184,756 equals, so that's 64350 over 184,756. Let's see, both of those are at least divisible by 2. 184,756. This reduces to 222 over 646. Oh, you're right. Calculadora, you can get further. Oh, wait. Sorry, I lied. 225. How sad. But you would have been right, Amber. That would have been further reducible, which sometimes the calculators convert to minimal fraction form. Doesn't always work for some reason. And that, by the way, was about 34.83% likelihood of that occurring. Now, question. What if, I'm not going to have us do this out. I know this one asks for the odds. To find the odds, you would just subtract 225 from the denominator and have success over failure. What if I asked for the probability of at least 8 right? We're not going to do this out, but I want us to just at least understand what this would have looked like. What's the probability of at least 8 the same as? What was that, Henrietta? So that'd be the probability of exactly 8 plus the probability of exactly 9 plus the probability of exactly 10. Right? Is how I would do that. So we could almost answer this question. We would just have to find the probability of selecting 9 right. Yeah, we'll do that. Why not? So let's figure out probability 9. Let's do some side work here. So 9 right, that would be combo of the 15 he knows how to do, selecting 9, of the 5 he doesn't know how to do, selecting 1, and then combo, what was it, of the 20, selecting 10. Because this is the sort of question that Carl's probably interested in, right? Like, he's like, I just want to do, 80 or better. So all 3 of those are good possibilities in his mind. He doesn't care if he gets exactly 8 right or exactly 9 right. He just wants, one of those possible outcomes. So let's see, 15 combo 9 is 5,005 times 5. I'm just going to simplify this. 25025 over the same denominator we've been having this whole time. 18475 and that reduces. Well, actually, maybe we don't want to reduce it. Well, I guess we could real fast. 184,756. Math rack. It reduces to 175 over 1292 is the probability of exactly 9 right, which is about 13.5% chance of that occurring. So I just want to point out, using the non-reduced versions might be interesting. This is the probability of 9. This was the probability of 8. And this was the probability of all 10. Or I could have just added the percentages if I was only interested in a rough percent estimate and add those all together. Yeah, let's just do the percentages. So that'd be 1.63 plus 34.83 plus 13.5. So I'll write that out here. Equals, so that was, I mixed up which one was what. Probability of 8 was the most likely. 34.83% plus probability of 9 we just found was 13.5%. Probability of 10 was the least likely, that was the 1.63%. So that's equal to 49.96%. So I would say that Carl has a 50% chance, roughly, of getting at least an 8 out of 10 on this quiz or test, whatever he's doing. Right? So that's kind of an interesting way to be able to break that down. I just want to point out once again the specifics of exactly 8 right versus at least 8 right, and how you'd have to find those all differently. Well, thanks for watching, Internet friends. Have a good day. Bye-bye.